Okay, so in this video, I'm going to go over section 10.4, which is preparing the test to claim about a mean. So we're going to do one example and go through all of the steps for that one example. Know that you'll see each of these examples individually with different scenarios for the most part. So a student claims that as stats students at her school spend on average a half hour doing statistics homework each night. In an attempt to substantiate this claim, she selects a random sample of 6 of the 62 students that are taking statistics currently and asks them how much time they spend completing statistics homework each night. Here are the data in hours, so 0.25, 0.5, 0.5, 0.75, 0.75, and 1. She would like to know if the data provide convincing evidence, statistical evidence that the true mean amount of time that the statistics students spend doing stats homework each night is different than 1/2 hour. So in some of the examples, it will ask you to identify what the appropriate null and alternative hypotheses are. So H0 is our null hypothesis. That's what she's trying to substantiate. So I'm using the percentage or the value, sorry, not percentage because it's not a proportion, the value that she's claiming is the amount of time that students spend doing homework each night. And she says it's a half hour. So this is our mu naught value. That's the value for our null hypothesis. So a half hour is 0.5. In an attempt to substantiate this claim, she selects a random sample. So she is claiming that it is different than 1/2 hour. So remember that this piece is what's giving us all our alternative hypothesis. So remember, is different means not equal to. It might say more or less. In that case, we would use a less than or greater than symbol. So in this case, that means that we're looking at a two-tail probability. So we're going to have either a t value or a negative t value, and we're going to have to find the probability of those two tails. Remember that it's symmetric, so it's going to be the same value. So when we find the p-value for one of them, we're just going to double it to find the other. So this works the same way as it did in the normal distribution with the t distribution. And so then mu is always going to be the true mean, meaning it's going to come from the population. So in this case, it's the true mean amount of time that stats students spend doing homework each night. I'm just going to copy and paste that for this. And so that is what our population parameter is, right? We're looking for the real value, not the values from the sample. So notice that they gave us the amount of things in the sample and they gave us the values for the sample. So that means we're going to have to calculate a mean and a standard deviation. Some problems will just straight out give you the mean and standard deviation. Either way, we want to check the conditions for inference. So a reminder that the 3 conditions for this is that it's done randomly, samples are collected randomly, that 10% of the, less than 10% of the population is polled, and that it's either normally distributed population, a large sample, or if my sample is not large, there's no strong skewness or outliers in the data. So random, we're looking for the fact that she collected a random sample, which it says here. Oops, let me change that color, sorry. She selects a random sample of 6 of the 62 students. So that's going to help us with the 10% condition. So 6 out of 62 is going to give us 0.096, which is less than 10%, which is 4.1. Remember that this condition doesn't have to be checked if I'm doing an experiment. So an experiment's not when I just have 2 groups, but when I have 2 groups where they're providing treatments, is kind of a hint to you to where the 10% condition does not apply. So that is less than 10%. So that means that condition was met. The last condition is the fact that it's either normally distributed as the population, which it doesn't say there. The sample size is not greater than or equal to 30. It's only 6. And then if it's not greater than 30, we're checking for skewness or outliers. If we look at our data, 0.25, 0.5, 0.5, 0.75, 0.75, 1, that's pretty well distributed. There's a bulk in the middle. It looks fairly symmetric. Everything's a 0.25 apart with a little bit extra in the middle. So that is going to pass from that condition. So we are able to use a t-distribution. For some of these, it might say like, oh, 2 conditions were not met, 1 condition was not met, all the conditions were met. It might not have you actually identify which ones were met and not met. But that is how you check each of them. Where 10% is only not applicable for experiments. Okay, the last 2 things are kind of come hand in hand. Example 3 and 4 are going to have us find the test statistic and p-value, and then tell whether or not we're going to fail to reject or reject our null hypothesis based on that p-value. So in this problem, because they gave us a data set, the way that you want to do this is to go into Desmos and enter that data set. So I know that I have a sample of 6, so I should have a 6-element list when I enter into Desmos. And I went ahead and just screenshotted that so that I don't have to take the time and type. So remember that it helps to name a data set. So I named this data set A. And so I entered the data. It doesn't have to be in order. It was there. So it's telling me I have a 6-element list. So I know that I'm good. Double check your numbers are good. It gives me a mean. This is X bar. And then if I find standard deviation of A, that is S sub X. So remember that when you're finding the mean, you could just type those words in, or if you get the keyboard and then hit functions and stats, mean is here. So you can hit that button and then type your capital A. And standard deviation is this one, not the one with the P. So regular standard deviation of a sample, not of a population. And then we're going to use those values in the formula to find T, our test statistic. So the formula for T is as follows. The mean of the data set minus mu naught, which is our value that we're testing our claim against, divided by the standard deviation of the data set, divided by the square root of the sample size. Okay, so if I look at this data from Desmos, I have that X bar is 0.625. I also have that the standard deviation is 0.262. I'm just going to use 3 decimals because that one had 3 decimals. Remember that from here, this is our N is 6. And then mu naught was the value we were testing in our null and alternative hypothesis. That's the 0.5 value. That's our mu naught. So it's the mu from H naught. So what we have to do now is plug these values into the formula for T. So T is going to be equal to 0.625 minus 0.5 divided by 0.262 over the square root of 6. So you want to plug those in the calculator. You can just type it straight into Desmos to make it look like that, using division to make a fraction, or they have a fraction button in there. Doing this, we get a value for T of about 1.17. So that's our test statistic. T is about 1.17. Remember that we talked about this is a differs situation. So that means that I really want to know what is the area on the tails to the right of 1.17, which is what the t-distribution table will tell me, but also to the left of negative 1.17. And so remember that in the t-distribution, critical values, they only give us positive t values inside the table. And so when you get a negative t, it's symmetric. You're just looking for the positive version of that t as well. Okay. So one thing that we need to do in order to find the p-value is to identify the appropriate degrees of freedom. So remember that the degrees of freedom is related to the values for n. And to get that, I'm going to subtract 1 from n. So since n was 6, that means that the degree of freedom that I'm looking for is 5. What that tells us is that we're looking here for our values for t. Okay, so we're looking in that section to find t. And so when we're looking at this, we're trying to figure out, okay, what is the closest value to t that we have? So t is 1.17. So I have 1.56 and 1.476. So that means that t is somewhere between those two values, because our t value is somewhere between them. Okay, so what that means is that the p-value is somewhere between those two numbers. So what this means is that over here, this is somewhere between, 0.10 and 0.15. Remember that it's symmetric. So that means that over here is also between 0.10 and 0.15. So somewhere between 10 and 15% between those values. Since I want to know the p-value of differs, right? So if it was less than, I would use something different. If it was greater than, I would use the between 0.1 and 0.15. Because it's differs, I'm going to double that value or add these two together. Okay, so this means that it's going to be between 0.2 and 0.3. So I'm going to double each value when our alternative hypothesis is not equal to or differs. Okay, so we did kind of a lot. So remember that if I don't have mean and standard deviation given to me in the problem, some of them will, I have to plug my data into Desmos and calculate that mean and standard deviation, use those values in the formula for t to find a value for t. Now the t table doesn't work quite as great as the z because of the way that it works backwards. And so you're looking for an estimate of t. So t was between 1.156 and 1.476 with a 5 degrees of freedom because our sample size was 6. So we always go one less. That tells us that the p-value or our tail probability is between 0.1 and 0.15. So since I'm doing differs, I'm doubling that value because I also want to see the symmetric probability. So that means that my p-value is between 0.2 and 0.3. So the last type of thing that you'll be asked is to draw a conclusion based on a significance level they'll give you in the problem. So this case, alpha is 0.05. So remember that our p-value is from 0.2 to 0.3. And so both of those values are greater than alpha. So that means that we are going to fail to reject the null hypothesis, which means that there is not convincing evidence that the true mean is different from 1/2 hour. So remember that if that was less than, we would reject the null hypothesis, which would mean that there is evidence for the alternative hypothesis. Okay, so when we're doing a t-distribution, remember that the t-values are the inside part of the table. We're looking for degrees of freedom on the left side, and then our answers across the top when we're finding our p-values. So hopefully this helps you work on that section.